Hello and welcome to this short video. My name is Johannes Ganzert and I'm an application engineer for oscilloscopes at Rohde and Schwarz in Munich. Today I'd like to show you some signal integrity analysis debugging on USB 3 signals. USB interfaces are very common, not only in the computer world but also in embedded designs, and therefore the demand for signal integrity debugging is increasing more and more. Today I'd like to show you how you can do this using our 8 GHz oscilloscope RTP. For demo purposes, I'm going to use this memory stick USB, and we have a test fixture that connects the transmit signals of the memory stick to the inputs of the oscilloscope. When these signals are terminated by the 50 ohm inputs of the oscilloscope, the device will automatically go into a compliance mode and send a pseudo-random data pattern. I will power up this device, and you can see you automatically have the signals. So now I'm going to adjust the oscilloscope, vertical settings first. I'm going to choose some horizontal settings that allow you to see the eye diagram. "40 picoseconds is a good value for USB 3 signals. I'm going to trigger on both edges so that we can see the eye. And now we will shift the horizontal position to the left so that we can see not the edge at the trigger point, but at some subsequent edge. You already see the typical shape of an eye, and to highlight the probability of the signals, I will turn on the color table. And this is a picture that already looks very familiar for an eye diagram. Now let's go and do some measurements. First of all, I will use cursors to do some manual measurements on the eye. For this, I'm going to select the cursors from the toolbar, both horizontal and vertical cursors, enable them on channel 1, and move them both horizontally and vertically. In the results window here, you automatically see the first parameters of the eye. Another important tool for signal integrity analysis is using histograms, and we can do that on the instrument as well. For that, I'm going to select the histogram from the toolbar. I'm going to choose the horizontal histogram, and for definition, I simply draw a rectangle over the area of interest, and then I use the knob for fine-tuning the area for the histogram. I'm going to make it as small as possible in the vertical dimensions, and then you can immediately see the bimodal distribution of the edges. This is very typical for a data signal on USB. An additional aspect for signal integrity analysis is mask testing. For that, we also have a tool. Again, I'm going to select the tool from the toolbar, mask tool, and the easiest way of defining a mask is simply by defining the points with the touch screen. And finish the mask definition. You get immediately the mask test results, and as you can see from the results window, the update rate is extremely high. That reduces test time a lot, and you get significant results from the mask test. Of course, we not only have this very user-flexible way of defining masks, but for typical data signals, we also have defined masks, predefined shapes, and that you can select from the advanced setup. So you switch from the definition type user to definition type I. And then in the mask definition, you select the shape of the mask. You can use typical shapes, for example, the hexagon, and then you define the typical parameters of a mask, the height, the width, and the position, of course. I showed you the cursors for the manual measurement. We also have automatic measurements for the eye definition. I'm going to close the mask testing tool. I'm going to close the cursors, and I'm going to use the measurement tool to define some eye measurements. For that, I'm going to select the category eye, and I'm going to enable typical eye measurements, like eye width, eye height, and period jitter, for example. I'm going to apply it to my channel, and down here you immediately get the results of the automatic eye measurements. That was already the part of signal integrity debugging on the analog aspects of the USB signal. We also offer some protocol level decoding, but that's going to be the content of an additional short video. Thank you for your attention. I hope you enjoyed this video, and I'm looking forward to seeing you again. Thank you.